Hello guys, my name is Bappy Ahmed and welcome to my course. So guys, in this video, we'll be implementing one end-to-end generative AI project called end-to-end medical chatbot. So I think you already know what is medical chatbot. Let's say if you have any medical related query, let's say you got one disease. So you are asking for the diagnosis, you are asking for the medicine. So this bot will able to give the response with respect to that. That means it will give you the suggestion, it will give you the medicine suggestion, it will give you the diagnosis suggestion. So these kinds of information this bot will provide. So we'll be creating the complete system here. That means here first of all we'll be using our custom data. The entire, let's say, medical information custom data will be using. First of all, we'll be teaching our model, we'll be creating the entire knowledge base. Then I'm going to connect my large language model there. So that means whatever information you'll be asking related the medical, let's say any kinds of disease, any kinds of medicine, any kinds of, let's say, diagnosis. So everything your chatbot will be able to give you the response. Okay, so this is the system we'll be implementing. And this is not going to be, guys, like notebook implementation. So here we'll be creating the complete pipeline. That means we'll be creating the front end part of our application. That means we'll be creating the beautiful user interface so that user can put the query and they can get the response from the chatbot. Fine. And here we'll be using something called modular coding in Python. So it's not a like scripting programming we'll be writing. We'll be using modular concept here to implement the entire project. Fine. And also we'll be using the Git and GitHub to, let's say, do the version controlling. So that means we'll be following the entire development pipeline here. What are the things you need? Even I will also show you how we can deploy this project, okay, in a cloud platform. So everything, guys, will be implementing in this project. So make sure you're watching this video till the end. And if you have any question, you can feel free to ask me, okay, in the comment section. So first of all, what I will show you guys, I'll show you the entire project architecture, like what are the things we are going to develop. Then I will also show you the tools and technology we'll be using here. Then we'll start the implementation. Fine. So let's open up our Blackboard and try to understand the project architecture. So guys, as I already told you, we'll be using our custom data here. Okay, we'll be using custom data, custom medical data. I can write medical data. So let me show you, I'm having one entire actually medical book. So guys, you can see this is the book. The book name is the Gale Encyclopedia of Medicine. Okay, second edition. So this is the book. You can also search on Google, you will get this book. And it is having around 637 pages. It's like very big book, and it is having all kinds of information regarding the medical. So see, if you open this book, actually, you will see all kinds of content. Let's say all kinds of disease, even with respect to that disease, what kinds of medicine actually you need, what kinds of diagnosis technique you need, everything this book has covered. Okay, so it is having different treatment, different actually medicine, different disease. Even the disease image is also visible here. All kinds of disease actually it is having. Even with respect to that, they have also given the diagnosis, or even the treatment. Okay, how, let's say, you can do the diagnosis, how you can do the treatment, what kinds of medicine you have to, let's say, take. Everything this book has given the information. So here we'll be using this book, actually, the entire medical information, and we'll be creating the knowledge base. That means here we'll be using Pinecone vector database. Okay, I think you know Pinecone is a cloud-based vector database. That means there we can store the embedding, vector embedding. That means first of all, we will be extracting all the information from this book. Then we'll be creating the chunks, and that chunks actually with the help of embedding model will be creating the vector embedding, and that vector embedding will be storing to the Pinecone vector DB. And that Pinecone vector DB is going to be my knowledge base. That means the entire knowledge base. Why I'm not using the local vector database here? Because my data size is huge. If you see 637 pages information I'm having. So if you just create the chunks, just try to consider how many chunks you will get. And if you're storing in the local DB, it won't be efficient. So that's why we'll be using cloud-based vector DB here. Fine. And I'll show you how we can use the Pinecone properly. It's one of the amazing vector DB even I personally prefer. So there actually you can also see your vector visualization. Okay, everything you can see. See, this is another actually disease. See, this is the disease actually. Even with respect to that, they have also given the diagnosis as well as the medicine. Now I'll share this PDF with you guys. You can see the complete book if you want to see different medicine and different let's say diagnosis. Okay, you can check it out. So here what we'll be doing, guys, we'll be using this medical book. So let's say this is one PDF documents actually I'm having, or here I can write medical. Okay, medical book. So from the medical book, what we'll do, we'll just extract all the information. Extract all docs. Okay, Then after that, we'll be creating different chunks. And I think you know what is chunking is required, right? Because here we'll be using large language model, and large language model is having input actually size, one specific input size, and we have to follow that input size. I think previously we learned about llama. Llama is having 4096. Okay, this is the input length. That means this is the maximum input length it can take the data. If you're using OpenAI model also, let's say GPT. Okay, GPT is also having one specific input length. If you want to see that, just open the openai.com and go to the model section. You will see that GPT input length. So whatever actually large language model you are using, first of all, try to see the input length, okay, of that model. Like what would be the maximum token size. Based on that, try to perform the chunking operation. Okay, that should be my suggestion. Now it will give me different chunks. So let's say I will get chunk 1. Okay, chunk 1. We'll be getting chunk 2. We'll be getting chunk 3, and so on. Then after getting the chunks, what I have to do, guys, I'll be using one embedding model. Embedding model. Okay, with this embedding model, we'll generate the vector embedding. Okay, it will give me different vector embedding. So you'll be getting vector embedding. I can copy and I can paste it here. So we'll be getting different vector embedding. And with this vector embedding, guys, what we'll do, we'll just try to build one semantic index. That means the knowledge base, right? Build semantic index. So this is going to be my knowledge base. That means we'll be storing this vector to the vector database. So I can write knowledge base. Okay, knowledge base. And here we'll be using something called Pinecone vector store. Okay, so let me just write vector db. Okay, db vector db. And guys, this is going to be my complete backend component. Okay, so here I can write this is going to be my backend component. Okay, component. Now I have to work on the front end component. That means user will give some query, and with respect to the query, actually I have to give the proper response. Okay, let's say this is the user. This is the user. So user will send one query. Let's say this is the query user has asked. So first of all, it will convert to the query embedding. Okay, query embedding. That means this is going to be an English text, right? And that should also convert it to the vector embedding. This vector embedding will go to the knowledge base. Okay, it will go to the knowledge base, and knowledge base will return some rank results. Okay, rank result or similarity. Let's say result it will return. Okay, rank results. So then I'll be using one large language model. So here we'll be using one large language model, LLM. So here I'm going to use OpenAI large language model. You can use any kinds of large language model. You can use open source large language model. Okay, you can also use the Gemini. You can also use let's say Mistral, anything you can use here. So here I'm going to use OpenAI large language model, because here I'm going to create a production ready application. So this application will be also deploying in the cloud platform. Okay, that's why I'll be using OpenAI model. Okay, why OpenAI model? Because OpenAI model is already hosted in the OpenAI server. We can access this model through API request. But if I'm using any open source large language model, we have to download this model in our local machine. And local machine doesn't have like good configuration, let's say instance. Let's say you don't have good configuration GPU, you don't have good configuration actually RAM, CPU. That time actually you can't execute this model in your system. Okay, it will be very much difficult for you. And you will see that inference time would be also very high. That means this model will keep processing the input. It will take lots of time to give you the response. So that's why we'll be using OpenAI model. And going forward, I'll be discussing about LLMOps, and there I will tell you how we can also use like different open source large language model. Let's say if I want to use Llama. Okay, Llama. If I want to, let's say, use Mistral, Falcon, okay, Cloudy, any kinds of model if I want to use, how I can use it, even how we can use it as an efficient way, even how we can deploy these are the model in the cloud platform. So for this, we'll be using something called LLMOps. Okay, LLM ops will be using. That means we'll be using different platform. We'll be learning about Bedrock. Okay, AWS Bedrock. We'll be learning about, let's say, GCP Vertex AI. So these are the LLM ops platform. Okay, So we'll be using this LLMOps platform to access these are the model, and on top of that we'll be creating the application. Fine. So this is what actually we'll be explaining later on, guys. So first of all, try to see how we can implement this production ready project with the help of OpenAI model. And that is another reason actually we are using OpenAI model, because if I let's say if I'm using open source large language model, you will see that open source large language model size would be very huge. Let's say around 10 GB, 20 GB. And this model you can't execute in your local machine. That means your low configuration machine. And if you're deploying this project to the cloud platform, there you have to take good instance. That means you have to take GPU based instance with higher RAM, higher CPU, higher GPU, and just try to consider about the cost, like how much cost actually it will take that cloud platform. You can go to any kinds of cloud platform, you can see their instance actually type. If you're taking GPU based instance type with higher RAM, higher let's say CPU, you'll see that per hour it will cost you like more amount of money. Okay, so again you are increasing the cost here whenever you are using open source large language model. Okay, without any kinds of LLMOps tool, LLMOps platform, you will get the difficulty for sure, right? So that's why we'll be using here OpenAI model. Although it will charge you, but it will charge you less than the open source model actually will be hosting in future. Okay, this is the idea here. So now what will happen? This rank results will go to the LLM. Even this query also will go to the LLM, and LLM will process. LLM will try to understand the query as well as the rank results, whatever results actually your knowledge base is returning. Based on that, it will give you the correct response. Okay, correct response. Or you can talk about answer. Correct answer. Let's say you are asking one question. Let's say I got fever. What can I do? So it will first of all refer the knowledge base. It will try to find out the, let's say, fever diagnosis, fever medicine. Then with respect to that, it will give you the response. Got it? So this is the entire system actually will be implementing, and this is what actually our front end. So this is what actually our front end. Many people also ask me like, sir, just try to create some application with the help of good front-end development as well. So that's why I also kept this front-end development here. We'll be creating one beautiful user interface so that user can give the query here. I think you use the ChatGPT. ChatGPT is having one beautiful user interface. Okay, so we'll be also creating this kinds of chatbot kinds of interface so that user can give any kinds of query and they can get the response. Fine. So this is the entire architecture of our project, guys. Okay, I hope it is clear now. Now, technology-wise, I already told you. Here we'll be using a large language model, OpenAI. Okay, OpenAI, LLM will be using. Then here we'll be using LangChain as a generative AI framework to develop the entire project. Then here we'll be using vector database, wise Pinecone. Okay, Pinecone is a cloud-based vector database. Okay, so there actually you can create a instance and you can store your vector. And here to create the user interface, we'll be using something called Flask. Okay, Flask is a Python framework. You can create web application. Okay, with that. Got it? Yeah, so I hope these are the actually technology we'll be using as of now. And if I need it, anything, I'll tell you, okay, later on. Now, guys, what I have to do, guys, first of all, let's create one. Yeah, so let me also write, we'll be also using GitHub. Okay, GitHub to do the version controlling of our entire application. Fine. And later on, we'll be also deploying this project to the AWS cloud. Okay, AWS cloud. So we'll be learning about the simple deployment as well as the CI/CD deployment. Okay, both will be learning. So guys, this is the entire agenda. So now let's open up our GitHub and try to create one GitHub repository first of all with our project. Then we'll be starting with the implementation. Fine. So I'll go to my GitHub, guys. So this is my GitHub. You can also follow me here. I have created lots of repository that might help you a lot. So just go to the repository and here create one new repository and give the name. Let's say I want to create a medical. I'll just write end-to-end. Okay, medical chatbot generative AI. So this is my repo name. You can give any repo name as per your requirement. Now I'll be keeping it as a public repository because I want to share this code with you so everyone can see that. I will add the readme file as well as I will add the .gitignore file. So here I'll be using Python programming. I'll be selecting the Python. Let's take the license. You can take any license. I'll be taking AMIT license. Now everything is fine. Now let's create the repository. Okay, now let's clone the repository. I'll copy the link address. Make sure you selected HTTP one. Now open up your local folder. So let me open up my local folder and here I'll open up my terminal. You can open up your, let's say git bash, you can open up your anaconda, anything, and just write the command git clone and press the link here. So it will clone that repository in your local machine. Now see, it has cloned. Now let me go inside this folder. You can see currently I'm inside LangChain project. Okay, now I want to go inside this folder. So I'll just write cd. Cd means change directory. I want to go inside end-to-end medical chatbot generative AI, this folder. Okay, now if I hit enter, you will see that I'm inside this particular folder right now. Now I'm inside this folder. Now inside this folder, I'm going to open up my VS Code. So let's open up my VS Code. So this is my VS Code, guys. Okay. Now let me zoom. Now the first thing, guys, what I have to do, I have to create one virtual environment here, because I already told you if you are creating any kinds of end-to-end project, first of all, create a virtual environment. Then you have to set up all the requirements you need here. So here, let me add all the steps you need to perform. So here I have added all the steps in the README file. First of all, you have to clone the repository. If you are using my repository, first of all, clone it, then try to create the environment with this command. So make sure you are using Python 3.10. Okay, so I'll copy the command. You can give any name. I have given LLM app. You can give any name here. Fine. So what I can do, I think use Medibot. Okay, I can use Medibot. You can use any name. Now let's create the environment. So guys, as you can see, my environment is created. Now let's activate. For this, you have to execute this command. All the command I have shared in the README file, just try to copy paste. And I will also push this code in my GitHub so that you can see the changes. Now see, medical bot has been activated. Fine. Now the next thing, we'll be creating one file called Requirement.txt file. And inside that, I'll be mentioning all the requirements I need. And we'll be installing all the requirements here. So guys, here are the requirement list. So these are the requirements actually I need to implement this project. We'll be using sentence transformer, because here we'll be using open source embedding model to generate the vector embedding. So that's why we'll be using sentence transformer, and sentence transformer uses actually transformer library. That means it will use Hugging Face platform, Hugging Face hub to download that model, open source model. And with the help of that model, actually we can generate the vector embedding. And here I'm installing one specific version. You can also install the latest version, but this is the stable version I'm installing so far. Then LangChain, I think you know LangChain. Then Flask we need for the user interface. Then PyPDF, here we'll be using PDF document, that's why. Then Python.env, why? Because here we'll be managing one .env file. Okay, .env file. So inside .env file, we'll be mentioning our OpenAI credential, as well as we'll be also mentioning our Pinecone credential, because Pinecone, you also need to use one API key to authenticate with your account. Fine. Then you can see I'm installing Pinecone, and if you want to install Pinecone, you need to install this tool library, Pinecone grpc. Okay. Then you need to also install LangChain _Pinecone. Then LangChain community, LangChain OpenAI, and LangChain experimental. Okay, so these are the dependency packages you also need to install. So let me install all of them. I'll just try to save. I'll open up my README file. I'll copy the command, and here I can execute. Now see, it will install all the packages one by one. So it may take some time, guys. Let's wait. Once installation is completed, I will come back. So guys, as you can see, my installation is completed. There is no error. That means congratulations, you have installed successfully everything. Now let me minimize the screen. And now let me save everything. Yeah. Now see, whenever you are implementing any kinds of end-to-end projects, the first thing you have to create the project. Okay, project folder structure. Structure. Okay, this is very much important, guys. That means you have to create the entire project folder structure, like in which folder, in which file you have to write which function. Okay, that's how you have to create the entire project folder structure. And again, this is your actually, let's say, design pipeline. Okay, it's not like that you have to follow my pipeline always. You have to follow my project folder structure always. If you feel like, okay, this folder structure is good for you, you can use it. Just try to design with respect to your project requirement, with respect to your, let's say, choice. Okay, no need to follow my one. But if you want to follow my one, you can also follow. I usually prefer one project folder structure. Okay, so I'll be showing you how we can implement this particular project folder structure. That means automatically we'll be creating the project folder structure here. So here we'll be creating one file. So the file name is template.py. Okay, this is going to be a Python file. So this will create the entire project template for me. So here only I need to give my one-time effort. That means I'll be writing the entire logic to create the structure. Going forward, whenever you want to create any kinds of project folder structure, you can execute this file. It will automatically create. Otherwise, what will happen? You have to manually create it. Let's say you want to create a folder. You will be clicking here. You will give the folder name. Let's say test. Okay, then I want to create another file inside folder. Again, you will be opening this folder. Inside that, you'll be creating another file. Let's say test.py. Okay. So this is like very time-taking task. Let's say you want to create 100 of folders, 100 of files. Just try to consider how much time it will take. Even you have to manually check everything, whether this file is present inside this folder or not. So it's not a efficient way to create the folder structure. Okay, you can create it, but I won't be suggesting you because it will take lots of time. So what you can do, you can create one template file. And inside template file, you can write one very Python basic code, and this code will automatically create the project folder structure for me. Let me show you how we can create it. So for this, I'm going to use some package. I'll be using operating system package. Then I also need something called path lib. Okay, so let me import. So from it is available path lib import. Okay, path. I need the path. Why I need the path, I'll tell you later on. As of now, let me import all of them. Then I also need something called login. Okay, so login is an inbuilt package inside Python. So here I will also log the information in my terminal. Fine. So first of all, you have to create a logging string. Okay, so basic logging configuration you have to create. So that's how you can create a basic logging configuration. See, okay, this is the basic login configuration. So here you have to write logging.basic.config. Inside that you have to mention the log label first of all. So here I need to create an information label log, and this is the format of my log. That means first of all it will save the ASCII time. That means the current timestamp. Like let's say whenever you are executing your code, it will save that timestamp. That means the time, date. So it will save everything. Then after that it will also save the log message, like which message you want to show. Okay, it will also save that. So whenever I'll execute the code, you will get it. Okay, what I have written here. As of now, just try to consider. You have to mention this logging string here. Fine. Okay. Now you have to give a list of the file you want to create. So let's say left hand side, I want to create some list of the folders and file. So for this, I have created a Python list. You can see. So the name of the list is list of the files. Inside that, I've mentioned I want to create a folder. You can see folder name is src. Okay, so it will create a folder here called src. Inside src, I want to create a file called init.py. That means __init__.py, and this is nothing but my constructor file. If you already familiar with OOP concept, I think you know what is constructor. So constructor is nothing but it's a special method. It's a, let's say, the magic function. It can execute automatically inside OOP. But you can also create this actually constructor as a Python file. Okay, so if you open up any kinds of end-to-end project, now let me show you. So if you go to any kinds of end-to-end repository, let's say if I open TensorFlow GitHub, it's an open source project, so I can also see their code implementation. See, they have also follow the modular approach. See, if I open any kinds of folder, let's say if I open Java folder or let's say Python folder. Now, if you just go below, you will see this constructor file is present here. Okay, why? Because they have created so many folders. You can see so many folders, and inside that they have created different Python file. So this folder would be considered as their local package. That means they can also import some functionality from this folder. Let's say I want to import, let's say this particular function. Let's say this function, import graph depth. What I need to do, I need to write. So what I have to write? I have to write from TensorFlow.python. Okay, then this file. And import, I want to import this function. Okay, that's how I need to import this file. That means instead of writing like all the function in just one file, what I'm doing, I'm creating a different folder. Okay, different let's say component. Inside that I'm keeping those functionality. Okay, and whenever I need it, I'll be using it later on inside my endpoint. Okay, this is called actually modular approach. And to whenever you are like following this modular approach, whenever you are creating this kinds of folder to keep your function in a file, make sure you are creating this constructor file, because this folder would be considered as your local package. Okay, because later on you have to import it. Let's say from TensorFlow.python import this function. So whenever you will be importing, make sure your Python interpreter will consider this is my local environment. Okay, that means I can import something from that folder. This is the idea. Okay, so that's why we are creating this constructor file, because src is my folder. Inside that I'll be creating one file called Helper.py. Okay, and Helper.py, inside Helper.py, I'll be writing all the functionality. Let's say I want to ingest the data. I want to, let's say, extract the information. I want to download the Hugging Face model. All the functionality I'll be writing inside Helper.py. Okay, this is the idea. Now, apart from Helper.py, I need another file. So inside src, I'll be creating another file called prompt. Okay, prompt.py. Inside that, I'm going to write the prompt. Okay, prompt, whatever prompt actually I need. The prompt, let's say whatever system prompt I'll be using, inside that I can write it here. Now I want to create a env file. Then I want to create a requirement.txt file. Oh, sorry, requirement is already created. I can remove it. As of now, I don't need it. I want to create a setup.py file. Why setup.py file? Because I want to install these are the folder as my local package. For this, I need setup.py. Okay. Previously, I think I already explained this part. Then app.py. Then I want to create a folder called research. Inside that, I want to create a Jupyter notebook file. That means trials.ipynb. So inside that, first of all, we'll be doing the Jupyter notebook experiment. That means the entire project will be implementing through Jupyter notebook. Then we'll try to convert everything as our modular coding. Okay, this is the idea. So this is my list of the files and folder I need. Now I have written a simple Python logic. Let me show you guys. It's not a very fancy code. It's a simple Python code I have written. So this code, it will loop through this list. one by one. That means it will loop through this list one by one. See, I'm looping through the list. It will give you the file path, the entire file path. Then you are giving this path to the path function. Why you are giving to the path function? Because see, here we're using Windows machine, and Windows by default use backward slash. I think you know. See, if I click here, see, Windows by default use backward slash. But which slash actually we're using here? We are using forward slash. Okay. But in Linux, Mac actually, they will be using this forward slash. But in Windows, you have to use backward slash. So that's why to I overcome this issue, we are using path, actually path library from pathlib. See how it will work. So let me show you one example. So first of all, I will open up my Python. Okay. Now here, let me first of all import. So from pathlib, okay, import path. Okay. Then let's define a path here. So I'll just write p is equal to test, let's say slash t.py. Okay, let's say this is my folder. Inside that I'm having one file. Now what I will do, okay, it has given me one error. Let me see the error. Okay, so test is not defined. That means I need to give inside a double quotation because it's a path, not. So it should be a string type data. Now fine. Okay. Now if I give this p to my path function, now see what will happen. It will automatically detect my operating system. Based on that, it will convert that part. See, it has given me Windows path. It has automatically detected my operating system. Based on that, it will convert this path to the Windows path. Let's say you are using Linux, you are using Mac. Automatically, this path would be converted to that operating system. Okay, so that's why instead of manually giving that path as a backward slash, what I can do, I can give to the path function. Path will automatically take care. That means we can execute this project in any kinds of operating system. Okay, otherwise, in some of the operating system, you might get some issue. Okay, that's why we have to always handle this kinds of scenario. Got it? So whenever you are designing your software, make sure you are handling this kinds of scenario and you are making your application more robust. That means in production, it won't be failing. Whenever it is failing in the production, this is not a robust application. Always you need to take care. Then after that, what I'm doing, I'm just splitting my folder name as well as the file name with the help of this actually function. So inside operating system .path.split. So what path.split will do, it will split your folder name and your file name. That means inside this file directory, it will give the folder name. Inside the file name, it will give the file name only. Okay. So you can also execute and test. So let me show you. So let's say this is my path now. So this is my folder and this is my file. Now if I use, first of all, let me import operating system. So if I give os.path.split. Okay, inside that I'll give the p. Now see, if I hit enter, it will give me one tuple. See, so in the first item, it should be my folder and the second item, it should be my file. Okay. And this is what actually I'm storing inside two variable. Okay, two variable. I'm doing the tuple unpacking here. Okay, I hope it is clear. Then first of all, I have to create the folder. Okay, I have to create the folder, and to create the folder, I'm using was.make directories. So first of all, I'm checking whether this file directory, it is empty or not. If it is not empty, that means definitely I have some file folder name here. So I'm creating the folder, you can see. Then I'm performing the login operation. I'm just doing the login in my terminal. I'm telling creating a directory, file directory for the file of file name. Okay, this is the log message actually I'm printing in my terminal. Then after that, I'm also creating the file. That means folder creation is done. Then inside the folder, I also need to create the file. For this, I have written this code actually. First of all, I have to check whether this file path is exist or not. If it is not exist, that means if it is not created, I have to create it. Otherwise, it is already created. Now I don't need to create it. And I also check the size of the file path. That means the file, it is 0 or not. Let's see if it is not 0, that means inside that file I have written some code. So I don't need to delete that file again. Let's say you want to create again. It won't be replacing that file. Instead of that, it will skip that file. So that's why I'm also checking the size. If size is empty, I'm creating this file, you can see, and I'm doing the login information. Otherwise, I'm telling this file is already exist. Okay. So this is the simple Python code I have written. Now see the power of this script. Okay. See the magic. Now left hand side, see, there is nothing. There is no folder structure, no file. Now if I execute this script, now see what will happen. I'll clear and I'll simply execute this template.py file. See, template.py. See, automatically it will create the folder structure for me. Got it? So it's just a one-time effort, guys. You have to like write this code only one time, and later on you can use it every time. Let's say you want to create another project. Copy this file, try to execute. It will automatically create a folder structure for you. Let's say in future I need some more actually, let's say folder, or let's say file. Let's say I need another file called test.py. I'll just add it here. make sure you are giving inside a string, okay, and you are giving a comma here because it's a list. Okay, now see, I'll execute it again. It will automatically create that for me. See, test.py is also created. That's how you can add as much as file and folder you need. Okay, it will automatically create. You don't need to manually create it here. Okay, this is the advanced ways to use this template.py file, guys. Okay, I hope it is clear. Now you can check it out. So inside resource, this trial.ip1b file is created. Now inside src, init created, helper created, prompt created. Okay, you can see init created, helper created, prompt created, .env also created, app created, setup.py is created. Okay, everything has created. So now let's set up our project as my local package. Okay, so for this I'll be writing the setup.py code, and this is a simple code, guys. I think previously I also shared. So this is the setup.py code. First of all, give the project name. That means the package name you want to give. Let's say Generative AI project, because if I show you currently in my terminal, inside my environment, this package is not present. So I'll just write pip list. See, Generative AI project is not there. Okay, so I have to install as a Generative AI project. Okay, for this we'll be using the setup.py. Now give the version, author name, email. Okay, and find package will try to find this underscore init.py, and whenever this init.py is present, it will consider this folder as my local package. Okay, let me show you. Now to install this one, you need to give one command inside requirement.file called -e space dot. Okay, -e space dot. This is the command. Now let me save. Now let me again install the requirements. Now see, automatically it will install as my local package. Now see, one egg info file would be created here, and whenever this egg info file is created, that means this project has been set up as my local package. Let me show you. Now if I again do the pip list operation, now see, Generative AI should be there. See, Generative AI project is there. Now it is my local package. Okay, that means now I can import anything from this src itself. Got it? So this is the entire idea. Now let's commit the code in my GitHub, guys. So for this, I'm going to open up my git bash, and here I'm going to write one command called git add, then git commit -m. Now let's give one commit message. Let's say folder structure added. Then let's do the push operation. So git push origin main. Okay, now it has pushed. Now if I want to check, let's go back our GitHub. Now let's refresh. Now see, it is pushed in my GitHub, and readme is also updated. Now you can copy all the command and you can execute in your system. Okay, I hope it is clear. Great. Now the first thing, we'll be doing the notebook experiment. Okay, first of all, we'll be implementing the entire project in our Jupyter notebook. Then we'll be converting as our modular coding. And after implementing Jupyter notebook, only you just need to copy paste operation. Okay, that's it. Now, first of all, let me select the kernel. So I already created one environment called medibot. Okay, so let's select it. Now let's test whether this is working or not. So I'll give one print statement. Let's say print okay. So this notebook should work. Now it is telling just try to install some IP1B kernel package. So let me install, because I'm using Jupyter notebook inside my VS Code. For this, you need some additional package, and it will automatically install for you. So it will take some time. After that, you will see that execution would be completed. So let's wait. Okay, guys. So as you can see, execution is completed and it is giving me okay message. Okay, it's fine. Now, one thing I just wanted to show you. Let's say if I show you my project working directory right now, let's say pwd. So I'm inside this resource folder. Okay, inside resource folder. But I want to load my data, and then my data would be present inside my data folder. Let's say I'll create a folder for data. Okay, inside that I'm going to move the PDF I'm having. Let me move quickly. So guys, as you can see, inside data folder, I'm having the PDF. Okay, PDF document. Now see, whenever you are implementing any project, make sure you are working in the project directory. Okay, that means your root project directory. So this is my root project directory, but currently I'm inside this resource folder. But if I want to get back, okay, inside my project working directory, so what I have to do, I have to execute one more command. So let me import operating system package. Inside operating system, you are having something called change directory. Okay, let me show you. So os.chdr, that means change directory to where one folder back. So for this, you can write .. slash. Okay, .. means, so .. means it will get back one folder back. Okay, let me show you. Now if I execute, now if I again show you the pwd project working directory, now see I'm inside my root project folder itself. Okay, so that's how actually you can check the folder location first of all. Okay, otherwise what will happen, you will get like path issue. Sometimes you'll get, there's a data not found and so on. Okay, so that to prevent this issue, actually make sure you are working in the project folder directory always. Okay, this is the suggestion I want to give you. So first of all, let's import some of the library here. So here I'm importing LangChain. From LangChain, actually, I'm importing PyPDF loader and directory loader because I have told you I will be using PDF documents. And to load the PDF documents, I need this PyPDF loader. It is present inside a directory. Okay, that's why I have given directory loader. Then I also need to perform chunking operation. And to perform the chunking operation, I can use recursive character text splitter. Okay, I think you're already familiar with these other things. Now let me import all of them. Now here to load the PDF, here I have written a function. Let me show you. So this is the function I have written, guys. Okay, extract the data from the PDF itself. So the function name is load PDF. It will take the actually data directory. Okay, data directory, and it will only load the PDF documents. Okay, it will only load the PDF document. Let's say you want to load the docs document, txt document. At that time, you can give the extension here. Fine. So with the PyPDF loader, it will extract the information from the PDF itself. Okay, and whatever let's say information it will extract, it will give me as a documents. Okay, you can see. Now let me show you. Let me execute. So it will return me extracted data. So here I've given the path. Okay, so it should be data. Okay, data directory. Now let me show you. So if I execute, now see it is extracting all the information from the PDF itself, and it is having almost 700 actually pages. So it will take some time. So let's wait. So guys, as you can see, my extraction is done. Now if I show you the extracted data, see this is the entire extracted data actually you got. Okay, from all the pages, it will show you the data. Now let me comment it as of now. Now what I have to do, I have to perform the chunking operation, because you remember, see the architecture, I have extracted the documents. Now I have to perform the chunking operation. Okay, and to perform the chunking operation, I will be using recursive text splitter. So with that, I have created another function here. So split the data into text chunks. So it will take the extracted data, it will perform the chunking operation, you can see. So here is the code. So chunk size is 500 and chunk overlay is 20 I have given, and it will perform the chunking operation and it will give you the chunk results. Okay, now let me show you. So now if I execute the function and if I show you the length of the text chunks, now see, you got 7020 chunks here, guys. 7020 chunks you got. Just try to see how much data actually you have in the PDF. Okay, and this is enough information to create one medical chatbot. I believe that. Fine. That's why I have taken this big data, guys. Now see, this is the entire chunks actually I got. Now what I have to do, I have to use one embedding model to like perform the vector embedding, and this embedding I'll be storing to the knowledge base, that means inside my Pinecone vector database. Okay, so now let's download one embedding model from the Hugging Face. Okay, so here is the function I have written, guys. Download Hugging Face embedding model. Now for this, I need to import this package. First of all, let me import. So this is the package, guys, Hugging Face embedding. I'm importing from the LangChain embedding. Okay, now let me execute. Now this function will automatically download one embedding model. See, this is the embedding model I want to use. Let me show you this embedding model. So this is present inside Hugging Face. So the name of the model is All Mini LM L6 V2. So this is one actually embedding model, and it will give you vector dimensional 384 dimensional vector actually it will return you. And this dimension you need because whenever you are using Pinecone vector database, you need to also mention the dimension of the vector, like what is your vector dimension. Whenever you are creating the cluster, now whenever you are creating the index, that time you have to mention this dimension. So that's why I always try to remember, whenever you are using Pinecone vector database, try to see what kinds of, let's say, embedding model you are using, and that embedding model returns what kinds of dimensional vector. Just try to see the documentation, you will also already get it. Fine. Now let me download the embedding model. So let me execute this function. I'll download the embedding model. See, it is downloading from the Hugging Face hub, so it will take some time. Let's wait. So guys, you can see my model has downloaded. Okay, now let's test the model, whether it is able to convert my sentence to vector embedding or not. So for this, I've given one sentence here, hello world, and there is a function called embed query. So it will automatically give you the vector embedding. And I'm also checking the length, whether it is giving me 384 dimensional vector or not. Now see, if I execute the program, now see length is 384. And if you want to see the vector, see, this is the complete vector actually you got. Okay, I hope it is clear. Now let me comment this line as of now. Got it. Now what I have to do, guys, I have to initialize my Pinecone. Inside Pinecone, actually I have to store, these are the vector. Okay, the complete vector actually I'll be generating from my text chunks. So for this, let's open up my Pinecone. So if you want to open up the Pinecone, just write pinecone.io. So this is the website, and make sure you created one account, guys. Just do the sign up operation with your email address. You can create an account. So for me, I already have one account. Let me log in. So guys, as you can see, this is my Pinecone website. Okay, this is the interface of the Pinecone, and this is one of the amazing vector database provider, guys. You will be loving a lot. Even I personally like it. So here, what I have to do, guys, I have to create a index. That means I have to create a cluster. In that cluster, actually, I'll be saving all of my vector. They have also given the quick start, like how we can set up the Pinecone, how we can, let's say, store the data. See, all the code example they have also given. Okay, so we'll be following the same approach to store our embeddings to the Pinecone. But before that, you have to collect one API key. So how to collect the API key? Left hand side, you can see one API key option is there. Just try to click here. For me, I already created one API key. If you don't have, just try to create an API key. Just give the name. Let's say I'll give test, or you can give any name. Let's create the API key. Okay, so this is the API key. Now just try to copy the API key, guys, and try to mention inside this .env file. So I'll open the .env file. So let me paste it here and make sure you are giving one key name here. That means this is your Pinecone API key. Okay, that's it. And make sure you are writing this thing in a string. Got it? Now let me open up my trials.ipynb. Now what I will do, I'll just create a cluster here. So let me go back to the database. And don't share this key with anyone, guys. Otherwise, they will be also able to access your account. Okay. I'll be removing it after this recording. So for you, no need to share with anyone. Now inside Pinecone, either you can manually create the index. Let's say you can click here, create index. Let's create one index. Let's say I want to create, let's say anything. You can give test. Now dimension, let's say 384. The same dimension I will give here. The dimension actually I'm getting. Cosine metrics, just keep it. You can also select different metrics, like what kinds of, let's say, similarity metrics it will apply whenever it will do the semantic search operation. I want to use cosine score. Now just keep it everything as default. You don't need to change the provider. See, AWS is the free one. If you're, let's say, sign up for the first time, you can create 1 to 2 cluster here with the help of AWS cloud provider. But if you want to take their premium subscription, that means if you want to create a multiple cluster, if you want to take some more space, you can see, if you're using free plan, you will get 2 GB storage here. But if you have more than 2 GB data, that time you have to take the premium subscription. Okay. That time actually what you have to do, you have to take their plan, subscription plan. Let's say if I take this one, Google Cloud. Now see the price plan. See, this is the price plan actually they have. So with respect to that, you can also purchase their, let's say, machine. Okay. But as of now, I'll be using the free services only. I don't need the, let's say, premium subscription of the Pinecone. But if you are creating the actual project, if you need more spaces, that time you can do it. So I'll be selecting the AWS cloud provider, and region, just keep it everything as default. Only just need to give the name. Okay, name and the dimension. That's it. 384. Okay. Now let's create the index. So this is the manual approach to create the index, guys. Okay. This is the manual approach. See, this index is getting created. It is getting initialized. And once it is initialized, see, it would be connected. Okay, see, it is now connected. Okay. Now, if you want to connect it, you can execute this Python code and you can insert your data. All the code they have already given. Okay. But I don't want to create this index manually. I want to create through the Python code. So let me delete it. So if you want to delete it, just click here and try to delete the index. So you have to give the name. Okay, I'll be deleting because I will be creating through the Python code. And how to create through the Python code, guys, I think they have already given one starter code. Remember? So here you can give the index name, like which index you want to create, and create index dimension you can give here, metrics, serverless, AWS, region. Okay, everything you can pass here. So now let's use this approach to create the index. So what I'll do, I'll go back to my VS Code, and I already prepared this code for you. So let me show you. So this is the code. Only you just need to change the API key. So let me change the API key. The API key I have collected here. Let me copy and let me change it here. Or I think I can read it from the environment only. So what I can do, I can import the environment. Just a minute. So let's import. So from .env, import load env. Okay. Then I will load the env. Now simply I'll get this Pinecone API key from my environment, and here it will save inside this variable. Now this variable actually I'll pass here. Okay, so nobody won't be able to see my API key that time. So this is the best approach, guys. You can also follow. Now you can give the index name. Let's say I'll give medical bot. Let's say this is my index name. And here you have to give the dimension. So make sure which embedding model you are using and what is the dimension size. 384. That means it's fine. 384. Keep everything as default: cosine, serverless, AWS, US East 1. Okay, no need to change anything because we are using free cluster here. Fine. Now, once you will execute this code, okay, once you will execute this code, you will see that your index would be automatically created in the Pinecone. Let me show you. So if I execute this code now, see what will happen. So guys, execution is done. Now if I get back to my Pinecone and if I refresh it here, See, medical chatbot should be created here. Let me show you. See, medical chatbot is created automatically. It has created, and now it is active and running. Okay, now what I can do, I can convert our let's say chunks to the vector embedding, and I can store inside the Pinecone vector database. So for this, what I can do, so for this, first of all, set this Pinecone API key as your environment variable, because whenever we'll be storing the, let's say, data to the Pinecone, so Pinecone internally looks for this API key inside the environment variable. Okay, so for this we are using operating system Euron. Okay, Euron, and this is the key name, guys, I'm giving, and I'm setting my Pinecone API key. Okay, whatever API key I'm loading from my .env file, so it will set inside my environment variable right now. Okay, so whenever I'll execute my Pinecone code, I don't need to like again and again pass it. Okay, again and again I don't need to pass it here. This is the advantage. Now see, to store the vector embedding, this is the code snippet you have to execute, guys. So you can see this is the code snippet. Let me comment here. Now I'm importing LangChain Pinecone import Pinecone vector store. Okay, now inside Pinecone vector store you have one function called from documents. So first of all you have to give the documents, that means my text chunks, the text chunks I have created, remember. So this is the text chunks I have created. Okay, so this text chunks you have to give, then you have to give the index name. So what is the index name I have given, guys? I think remember this is the index name. That means this index name it is already created. That means inside this index it will store the data. Got it? So make sure you check this at the variable. Now I need to give the embedding model. So I think remember we downloaded one embedding model, okay, from the Hugging Face app. Got it? So these three parameters you have to pass here. Now see, if I execute this line, it will convert all of my data to the vector embedding and will store to the Pinecone vector database. And how many chunks I got, guys? I think remember I got 7020 chunks. That means 7020 chunks vector would be stored inside my Pinecone. So it will take some time, guys. Let's wait. After executing this code, I'll pause the video, and once this vector will get stored in my Pinecone, I will come back again. See, let me show you. If I go to my Pinecone right now, and if you refresh the page here, see, all of the vector would be stored here. Even you can also see the count. Let me show you. See, as of now, 864, let's say, chunks has been added. Now see, 1000. Now see, you can also see the visualization of the vector. It's amazing, right? So whenever you used to use local vector DB, it was not possible to visualize our vector, but here it is possible. You can see. You can also see the score. That means semantic score. Like what is the score between this vector, and this vector? Got it? This is one amazing visualization, guys, you will get in the Pinecone. And see, this is the entire vector representation of this entire sentence. Okay, entire text. Okay, and even it is also showing the page number, in which page it is extracting the data, and what is the PDF name as well. Okay, every information you can see here. Even you can also perform the query operation. That means the way you perform the SQL query, you can also perform the query operation here manually. Everything is possible, but everything will be doing through the Python code. I'm not going to use the manual approach here. Now see the vector count, guys. So 4120 vector has been stored. Now let's wait. Once it has saved all of my vector, I'll come back and I'll show you. So guys, as you can see, my execution is completed. Now if I get back to my Pinecone and if I refresh, see, all of the vector it has stored here, like more than 7000 vector it has stored inside my Pinecone index. Okay, now what I can do, I can use this index as my knowledge base. That means we'll be connecting my large language model with this knowledge base, and we'll be asking the query, and it will do the semantic search operation here. Okay, this is the idea. Now let's get back to my code editor. Now see, I already created the index and I already stored my vector there. Now I want to load my existing, okay, existing index. If you want to load the existing index, what you can do, you can use this code snippet. Okay, see, again I'm importing Pinecone vector store from LangChain Pinecone, and there is another function called from existing index. Okay, from existing index, you have to give the index name. So the index name, I've given the same index name, and you have to pass the embedding model. The embedding model you have downloaded. Now see, if you execute this line of code, it will load the index. That means whatever index you have created and all the vector, actually it will load, and it will give you the doc search object. Okay, this is an object, doc search object. Now you can also perform the retrieve operation here. That means you can perform the similarity search operation here. Let me show you one example. There's a doc search as retriever, search type similarity, search keyword 3. That means it will give you 3 relevant answer. Let me show you. So if I initialize my retriever object, and now I will ask one question here. So this is my medical data. I will ask, let's say, what is acne? Okay, acne. So I think you know inside this PDF, I'm having acne related disease also. Let me show you. So if I press Ctrl F, acne. So guys, as you can see, this is the acne disease. What is acne and all? So you can see acne and acne related actually treatment, okay, medicine. They have suggested each and everything. So I'm asking one question here. So what is acne? So it should give me the relevant answer, okay, for the acne from my knowledge base. Now let me execute and let me show you. Now see, if I show you this retrieved docs, it will give you 3 results actually. 3 results. Even it is also showing the source, okay, from where it has referred. Now see, different actually acne related response it has given me. Okay, because I have set search keyword is equal to 3, it will only give me 3 response. Okay, but I don't need this kinds of output. I need a complete let's say definition. Okay, what is acne? Got it? So for this, what I have to do, guys, I think you remember I have to integrate my large language model. That means here we'll be working on user will give the answer query. This query will go to knowledge base will give the rank results. I'll be using the large language model. So LLM will process this rank results as well as the query, and it will give me the correct response. Okay, so for this, let's initialize my model. So I already told you we'll be using OpenAI model. So OpenAI, so let's initialize my OpenAI model, and I think you already know what is temperature and max token. So it is giving me one error. Okay, it is giving me error because I haven't set my OpenAI API key. So let's set the OpenAI API key. I'll open up my environment. So here is my API key, guys. So make sure you create one API key and just try to paste here. And similar wise, I also need to set this API key as in my environment variable. Okay, so let me execute this code. So here what I can do, I can duplicate this line, and here I can write OpenAI API key. So it will also give me my OpenAI API key. Then here, whenever I'm setting as an environment, here I can also change OpenAI API key, OpenAI API key. Okay, now let's set this one. Okay, string expected none time. Okay, so I think I have to load it again, then I have to execute. Now it should work. Now it is working fine. Now if I get back here, now if I initialize it, it should work. See, successfully I have initialized my large language model. Now I have to create the complete chain. For this, let's import some library. Previously I showed you how to create the RAG application. There I think you remember we were importing this library, create retrieval chain, create stub document chain, okay, create prompt, chat prompt template, okay, everything I already showed you there. So we are importing the same code here. Now this is going to be my system prompt. So here I want to give this prompt in my language model, okay, large language model. Now I'm going to create the complete prompt template. You can see this is the system prompt, and whatever input user will give, that means the input actually I have given, it will come here and it will give you the complete output. Now let me initialize. Now let's create my chain. So create stub chain. Inside that you have to give the LLM as well as the prompt, and whatever object you will get inside create retrieval chain, you have to pass it as well as the retriever. That means your vector store. The vector store you created, okay, retriever object. Now let's initialize my chain. Now let's ask the question. So here I will give what is acne. Okay, what is acne? Sorry, acne. Now see the response, guys. See, acne is a common skin disease characterized by pimples on the face, chest, and back. It is caused by clogged pores and become inflamed due to the oil, dead skin cells, okay, and bacteria treatment and so on. See, that means it has given me the correct response. If you open the PDF now, this book right now, and if you read it here, you'll see that it has given me the correct response. Now see, if I giving any other question which is not relevant about the PDF, what will happen? See, now see, if I give any other, let's say question, let's say I have given what is stats, that means what is statistics, it is telling me I don't know, because here I have given the prompt now. So if you're not getting the context, that means here this question I'm asking, this is out of context. That means the data I have given to my model, okay, the knowledge base I have given to my model, so this information is not available here. So that's why it is telling I don't know. Okay, so this is the complete custom system we have created, like custom chatbot we have created which is only referring our custom data. Okay, I hope it is clear. So guys, this is actually entire demo. Like that's actually will be implementing the entire application. Now you can ask any kinds of question. Let me show you. So you can take any other disease. Let me show you. Or let's take any other disease. Okay, let's take this disease actually. This one. I'll copy and I'll come back here. Then I'll ask here. Now let's see. See, it is giving you the response. Growth hormones resulting the abnormal growth. Okay. See, that means this is the correct response actually I'm getting. Now if you see the image, so the same thing. Okay. So you can see this disease is a abnormal releases particular chemical from the so blah blah blah. Okay, so you can read it. So that means we are getting the correct response. Fine. Now let's try to convert this project as our end-to-end implementation right now. That means we'll be also implementing the UI. But before that, I have to first of all create the modular coding. Okay. So what I'll do, guys, I will first of all open up my Helper.py. Inside Helper.py, whatever, let's say, utility related code I have written, let's say loading the data, then creating the chunks, then loading the embedding model, all the function I will move inside this Helper.py. So let me open. So inside that, I'm going to import all of the library. See, I just copy pasted the code from my notebook only. If you open the notebook, the same code actually I'm copy pasting. And why it is giving the error? Because below you can see I have to select my environment, the correct environment. Let's say medical bot. Now this error would be disappeared. Now see all the function I'll just copy paste here. All the three function I have written. My load PDF, then this one text split, and this one my load embedding model. So here I kept all the function, you can see, because I want to import from here. So these are the function I don't want to create inside my endpoint. Otherwise my code base would be like messy, right? That's why I am creating inside this particular file. Now let me save, and inside prompt actually what I will do, I'll give the system prompt, whatever prompt actually I have written. So here is the prompt, guys. I think you remember. I'll copy the prompt, and inside prompt.py I'm going to mention it here. Okay, so from here I'm going to open the prompt. Let's see in future you want to change the prompt, you want to give any other prompt, you can open this prompt.py, you can change here, it will reflect in your code. Okay, no need to open your actual code implementation that time. Fine. So let me close this at the tab. As of now it's not required. Now yeah, so helper is fine. Now what I will do, I will create another file here and I will name it as store underscore index .py. Okay, .py. Why? Because let's say you want to update this book, let's say you want to add some more information. That time again you have to store all the embeddings to the knowledge base, that means inside your Pinecone, yes or no, right? And to store it, I again need to execute one like endpoint, that means store underscore index.py. Whenever you will execute it, it will load the new information and it will store to the vector database again. Fine. So for this, what I will do, I'll prepare this one. So see, whatever code I have written here, that means I extracted my let's say documents, I created the chunks, downloaded the embedding model. After that, I pushed everything to my vector database. Okay, see all the let's say vector database code I have written, everything I need to write inside that one. So let me import all of the library. So you can see I'm importing from src helper, that means from src helper. So inside helper I'm having three functions: load PDF, then text split, and download face embeddings. Okay, see I'm importing all of them, Hugging Face embedding. Okay, then I'm also importing Pinecone, then Pinecone vector store, then load env and operating system. First of all, I have to set my environment variable, that means my credential. Okay, OpenAI, sorry, Pinecone API credential. Then I will be loading my data, extracting the data, creating the chunks, then I'll be loading the embedding model. See, load file, that means I'm loading the data, so I have to give the data location. So this is my data location. Then text splitter will run, then download the embedding model. Okay, then after that I will initialize my Pinecone code base. The same code, guys. If you open the Jupyter notebook file, the same code. See, Pinecone initialization, it will create the medical chatbot. Okay, medical bot, that means this bot it will create. Okay, then it will actually create the index, then it will store the embeddings. Okay, so at the very first time you have to execute this line, guys. Okay, very first time you have to execute this file. Then whatever actually, let's say data you are having, it will do the vector conversion, that means embedding conversion, then it will store to the vector database. Okay, now what I'll do, I'll just delete my previous embeddings, whatever I created. this cluster, I want to delete it because now I'm doing the modular coding na. So I'll be executing everything from my modular coding itself. Now let me remove it. Now see, it will delete it. After some times you will see that it won't be visible here. Now see, make sure guys, before launching your application, first of all, you need to execute this store index.py. Make sure this index should be created. Otherwise you won't be able to do the query operation, right? So at the very first time you have to execute this store index.py. Okay, then you will be launching your application, that means app.py. And this one you have to only execute one time, not multiple time. Multiple time when you will be executing, whenever you will update the data. Let's say you want to add any other data, one more PDF, that time you will be executing this file. Okay, otherwise just keep it as default. That's it. Now let me save. Now I think this is deleted. Now see, there is nothing. Now what I will do, let me show you how it will create everything. So I'll open up my terminal. Let me clear. Now let's execute this store index.py. Python store index.py. Now let's execute. See, again, it will perform all the operation, whatever things we have done in the Jupyter notebook. So let's wait. After sometimes you will see that your index would be created, and inside index all the vector would be stored. So guys, as you can see, my index is created. Now if I open it up, inside that, now it will store the embeddings. One by one, all the embeddings it will save. So guys, as you can see, my execution is completed and it has stored all of my vector. Now that means my this store index is working fine. I'm successfully able to store my vector. Now let's create the endpoint. Okay, that means my main application. So user will start this application right now. So here I already told you we will be using Flask. Okay, so here I already told you we'll be using Flask here. And if I'm using Flask, I need a HTML and CSS code to create the one beautiful user interface. So I already created one HTML and CSS code for you guys. If you don't, it's completely fine. Again, I'm telling you, there are so many templates you will get over the internet. There is a website called Bootstrap. Previously, I also told you, I think Bootstrap. Okay, Bootstrap website. So from here, you will get different example. Even you can also see different template it is having. Even if you search like Chatbot, HTML, CSS, free template. You will get different actually template. See, different template. You can also download the source code. Even see, code is also visible. You can also download. Even you will get some website. See, different chat template. Okay, different chat template. You can use it. Okay, it's up to you. Now, what I will do, I'll quickly just show you the HTML CSS code I have prepared. For this, I think you know, if you are using Flask, you need to create one folder here called template. Okay, templates. So inside that, you have to create a file called index.html. Okay, now let me show you my HTML code I have prepared. Or it's a chatbot. What I can do, I can name it as chat.html. Okay, chat.html. Now this is the entire HTML code, guys, I have prepared. Okay, save it. Now I need to create another folder for the CSS called static. So these are the requirement folder for the Flask. If you're using Flask inside Python, you need to create this other folder. Inside static, I'll be creating a file called style.css. Okay, now let me also paste the CSS code I copied from the internet. Okay, so this is one basic template I created. Now whenever I will show you my application, you will see the user interface, whatever the user interface I created. Now let me create my endpoint, app.py. Now inside app.py, I'll be integrating all of the functionality I have prepared so far. So first of all, let me all the required package actually, one by one. So here I'm using Flask, so I have imported Flask. From the Flask, I have imported all the required functionality, you can see. Then imported download Hugging Face embedding model. Okay, because I need the embedding object to load my vector store. I think you know that I need to load this, note this actually Pinecone index. So where is the Pinecone index? So here is the Pinecone index. So I need to load this index, and to load this index, what I need the, let's say this one, embedding object. I think remember at the last I showed you, loading existing index. Okay, I think you need it. Okay, I think remember. Fine. So that is why I have to import it. Then I'm importing, you can see Pinecone store, OpenAI, Retrieval, QA. That means whatever, let's say I was loading here. These are the thing I'm loading everything. Fine. Then I also need to load my prompt. So prompt is available inside my prompt.py. here, so I can import it. So simply I can import, just write prompt src dot prompt import start. That means I want to start everything inside that file. Okay, that's it. Then I also need something called operating system. So import OS. That's it. Now let me initialize my Flask. To initialize the Flask, you have to use this code. Go to the Flask documentation, you will get it. Now let's set all of my OpenAI and Pinecone environment. Okay. For this, I need to use the load in environment package. That's it. Then I will be downloading the embedding model. Then I will first of all initialize my embedding object. Then I will load my existing index from my Pinecone. So let me show you. See, the same code from the notebook I copied. See, so I'm loading the existing index, medical bot. Make sure name is correct. Medical bot. Yeah, it's correct. Then it will give me the retriever object. Then I'm loading the OpenAI model. Then creating the prompt template. Then after that, I'm creating the chain. Okay. Now I have to create two routes exactly. First route would be my default route. That means user will get the interface of my application. Chat.html would be rendered. Got it? Now second route I'll be doing for the chat operation. That means user is giving any query to the chatbot. So that message actually I'll be accepting. And this message I will give to my LLM. Okay. That means you can see I'm doing the invoke operation. Okay. So same invoke operation I'm performing. Let me show you. So here is the invoke operation. Remember, okay, invoke. And whatever response I'm getting, I'm printing it as well as I'm showing in my that user interface. Okay, that's it. Now let me execute my application. So I'm running on my local host, port number 8080, debug is equal to true. That means if you change anything, it will automatically update everything. So now let me show you my application. So let's open up my terminal. So I'll just execute Python app.py. Sorry, it should be Python. Spelling is not correct. Python. Okay, now it should be running. Now see, just give the allow permission. Now see, your application is running. Now let's open up our Google Chrome. Search for localhost port number 8080. See guys, this is the interface we have created. And this is one amazing interface, guys. You can see amazing chat template we have created. Because many people have requested me just try to create one front-end part of our application as well. Beautiful front-end part. And that's how we can create a beautiful front-end part. Now here you can ask any kinds of question. Let's say I will ask the same question. I'll ask what is acne. The acne is a common skin disease characteristic by pimples on the face. Fine. Then I will ask another question. Let's say I got fever. What should I do? See, now this is the response. If you are experiencing high fever, it is important to seek the medical attention. Okay. So tell me some medicine. Now see, it is also suggesting some medicine, okay, related fever. Now you can ask any kinds of question from the, let's say, PDF itself, any kinds of disease you can ask. Let's say this is the disease I want to ask. I'll just copy. And here I'll just write what is this disease and all about. See, it has given me the response. Okay, now you can read this, PDF, and you can see that you can ask the medicine, you can ask for the treatment, anything you can ask. So this is our chatbot, guys. This is our medical chatbot we have created. And see, it is also giving you the one beautiful user interface. Okay, it is also returning. Now, what we'll do, we'll just try to also deploy this application, guys. But before that, we'll be implementing some more end-to-end projects. Then after that, I'll keep one dedicated end-to-end, let's say, deployment session. There I'll show you how we can deploy this at the project on the cloud platform. Okay. So yes, guys, I hope you liked it. But before that, what I will do, guys, I will commit this at the code in my GitHub. So you can also commit from the VS Code. Let's commit from here. I'll write updated. Let's commit. And .env file would be automatically ignored by the git ignore, okay? Because inside git ignore, you have already mentioned it. .git ignore would be ignored. See, .env would be ignored, okay? So it won't be published inside my GitHub. Now if I open up my GitHub, now if I refresh, see, all the code has been updated. Now I can write the further code, let's say step as well in the readme file. Okay, so I have added all the step. Like after that, what you have to do, after that you can set your environment key, then run store index, then app.py, then you just need to open up your localhost. Okay, now let me commit the changes as well. So readme updated. And make sure guys you start this repository, all of you start this repository. You can also fork it so that you will have the reference. Okay, now if I refresh, now see readme is updated, and you can see all the step I have also added. That's how you can also prepare your readme file, so that if other people is referring your, let's say, GitHub, they will be also able to set up this code, okay, in their system as well. Fine. So yes guys, this is the complete implementation. I hope you liked it. So that's how we can create any kinds of end-to-end generative AI builds project. Fine. And no need to worry, I'll also show you the deployment. Even we will be also discussing about LLMOps. With the help of LLMOps also, we'll be learning how we can access any kinds of open source large language model. Okay, as a hosted open source large language model, we can use it. So yes guys, this is all about from this video. If you liked it, so please try to subscribe to the channel, try to like it, and try to share it. So thanks for watching, and I will see you next time.